Hello, this is Moses with Pages for Content magazine. I'm here with Brian Korsedal. He is the inventor of digitally fabricated housing, and I'm here to talk to him about his invention and what he plans on doing with it, his inspirations for it, and how you can find out more information about it. So we can start off with, so what was your inspiration for this invention?
So I just had a idea that would kind of haunt me. I do a lot of stuff with CNC machines, which are robots to cut metal or wood, and do a lot of things with programming and 3D printers and whatnot. And I've really wanted to do like a 3D printer that can make a house. But when you get to that kind of a stage, there's really like the same kind of things that work at the small scale that let us 3D print little plastic objects aren't going to work when you scale it up to the size of a house because of physics. So you kind of have to think outside of the box, and there's lots of different ways people are doing it. And I just thought that if you wanted to build something long term, something durable, something that's really going to stand up to the test of time, you'd use steel. And nobody really seems to be trying out steel. People are trying out quadcopters or laying bricks, or robots laying bricks, or they also have cement machines that are trying to print out houses, but I thought steel was the way to go. So I kind of just went for it.
So did you design the software?
Yeah, I wrote the software from the ground up. And what you do is you put in a shape into it, and it generates a steel space frame to match your shape, and it comes out as a bunch of parts that we just bolt together at parties.
Nice. How long did it take to develop the software?
It's an ongoing process. I would say it's not finished yet, so I can't really say that it's finished. We've been doing it for about, this will be, I think, 11 months. So it's not quite a year yet. A year will be around Thanksgiving time.
So it's been almost a year since it's been functional? Or?
No, almost a year since I started.
Oh, wow, that's actually pretty good.
Yeah. It was a really hardcore obsession when I started. I couldn't sleep. I couldn't eat. I just worked on it pretty much straight the first month or two. So it was an idea that kind of just grabbed a hold of me. I couldn't control myself.
So have you printed out many structures?
We've done 7 so far. Our 8th one is gonna be in LA at a show here. We're putting together a DJ booth this Friday.
Did you get an invitation to do it?
Yeah, got an invite to a show. We're not in the flyer yet because we're waiting till our Kickstarter goes on, and then we're going to go with the advertising for the Kickstarter, but then we should be in the flyer and all that kind of stuff. Mm-hmm. We're on a flyer at another event, November 15th through 17th. We're going out in the woods to build some stuff with a bunch of people. So
nice.
It's cool. We're like getting on flyers and getting it invited to events and stuff.
Nice. What are you going to be building out there?
Haven't decided yet. Might do we've done a couple of the it's kind of like a teardrop shaped structure. We might do this new one. It's a torus structure. It's like a knotted kind of twisty thing with 3 entryways. Usually every different time we usually do a different structure, except we've had a little bit of our designer's been just too busy to come up with new stuff, so we're just remaking old things.
How do you find your designers for?
They're hard to come by. So I thought, architects would be really good at it. I thought, people that are doing 3D printing would be really good at it. Very few people actually design for 3D printers. I've noticed there's maybe 1 or 2 here in Phoenix. The best place to find them is people who are doing 3D printed jewelry, usually for like shapeways or an online stuff. Usually people doing 3D printed art are the ones that are really good at it, even better than architects. I find architects they don't understand the technology that often.
Okay, so you say that you have parties to assemble these?
Yeah. So
like full-on parties? Or
oh, yeah, full-on parties. We have beer and pizza and a DJ, and the bars all have instructions on them, so it's kind of like assembling a huge puzzle. So you follow the instructions on the bars to assemble the structure with it goes together in parallel, so you get a bunch of people together and you can build stuff faster that way.
Nice.
Yeah.
What do you see the advantage of 3D printing over just like the conventional way?
Well, 3D printing, let me chop that up. 3D printing is pretty much awesome. There's like 2 types of people in the world right now. The people that know and love 3D printing and know that they need it, and the people that just don't understand it yet, but they're going to need it in the future. Basically, everything's going the way of 3D printed stuff. You can get jewelry right now. You can get all sorts of things around your house, doorknobs, whatever. We're not exactly 3D printing. Our user interface is like a 3D printer, so you put in a shape like how you would do a 3D printer, but we aren't 3D printing because we don't have the layers and it's not plastic or whatnot. We come out as a bunch of steel bars we bolt together. So we're sort of like, we sort of are a 3D printer, but we're sort of not. So it's kind of this weird gray area. But I think it's the future. I mean, I think everyone's going to need to do it. And the cool thing is you can do a structure in whatever shape you want. If you want to do like the structure, let's say you want to have a house that's a 100-foot long dragon, right?
Yeah.
Not a problem. You just throw it in there and it just makes it.
So you just have to assemble it?
You'd have to assemble it, yeah. But, you can't design a 100-foot long dragon for less than millions of dollars right now with today's technology. And we do stuff pretty cheap, so it's all computer generated. We're kind of a revolutionary breakthrough in the cost of design because you put in a shape and the computer designs it. You don't have to worry about it at that point.
Mm-hmm. So it's just is there particular equations you like? I'm not going to tell you to give away your software secrets.
It's actually a bunch of different equations. There isn't any kind of master equation. We more or less grow a structure more like a physics simulation or like growing a crystal or something like that rather than having an actual equation. It's kind of an iterative process that generally it takes a guess and then gets a little bit better and a little bit better. It kind of grows it. Yeah.
So does it print in the same way, like, at least in the format of it, like a layer, then layer, which is like which bar would go where?
Yeah. If you correspond the bars to the layers, then yeah. The manufacturing is completely different because we've got bars, we've got shapes, we've got sections, and you divide the structure into those different units. So you take all the bars and you assemble all the bars into shapes. Shapes are anywhere from like 3 to 20 bars that come into this little chunk of bars that all bolt together, and then you bolt all the shapes together into like a section, and then at the end all the sections bolt together. So we try to keep it highly parallel to make sure there's no bottlenecks. And if anyone was a 3D printer, it would be the people are the 3D printer following the instructions assembled on the instructions on the bars. It's kind of like a self-assembling nano material. You ever seen those, like where a bunch of atoms assemble a certain way or something like that?
I've never seen it.
Okay.
Well, I can see the analogy.
Yeah.
So the people. So it is partially 3D printing, but it's also manufacturing at the same time.
Yeah.
Uh-huh. So you say you've built 7 structures?
Yep. 7 so far.
What are they?
So the first one was a torus knot structure, but we didn't have the reinforcing that we have now, the kind of space frame truss system. So it wasn't all that strong, and it would it just wasn't strong enough. We had to tear it down. The second one, all the bars were off by about 5 inches too long. It was a bug in the code, so it fit sort of, but none of the angles were right. It was just kind of wonky structure, so we tore that one down. The third one was our first attempt at a space frame, and we chose a certain type of space frame that didn't work well at all, so we tore that one down too. The fourth one was we finally started to get the strength that we wanted, and it was a very strong structure, but it didn't retain its shape as well. It kind of slid around a little bit during assembly. We still have that one up at my house. The fifth one was just too strong. We went way too strong on it. We put these like huge half-inch bolts in it, and there was just no play in the structure whatsoever. It was just way too much strengthening. And then the sixth one, we finally got everything to work properly, and that one is actually on display at a big light show over in Mesa right now, and then we're going to throw it in at the firehouse probably after that. And then the seventh one is down at a side of heart, which is the nice little teardrop one that, once we get the first 6, we're just getting it working, and now we can really work on making it looking pretty.
Mm-hmm.
Yeah.
So how do you cover these structures?
You can cover them however you want. We can do fabric covers, which are fully full color printed fabric covers. We're covering the one down at the side of heart with a bottle wall, like what they use on Earth ships. We want to try out shrink wrap with a closed cell polyurethane foam and then stucco on the outside, which we think is going to be a really nice insulated wall.
Yeah, that'd be cool.
Kind of want to try out hempcrete. We're going to try out a bunch of different stuff and see what works. Yeah.
So you're still in a highly experimental part of the process.
Yeah, we got the frame working. We're working now on how to cover them and turn them into actual houses. it works with standard size windows and doors, so you can put windows and doors in the structure wherever you want, and it'll fit the bars to them. So if you want like a rectangular window, you just put a little rectangular window opening in the design, and it'll make it perfectly for your window. Same thing with doors. Yeah.
So do you have a team of people that you work with you to do this?
I have a bunch of volunteers who I would love to pay, but unfortunately we're just not. I think we're right on the verge of making money here, so hopefully everyone will start to get paid soon. But it's really just kind of a loose-knit team of volunteers. Yeah.
So how do you feel about the progress you've made within the year? Do you feel like you've just like...
I feel I'm doing pretty good.
Yeah.
I think
that's pretty good.
Yeah, the hardest thing has been trying to explain it to people. I think a lot of people, the technology is just too new, 3D printers and all this other kind of stuff. Like, people haven't even figured out, you say 3D printer, they think you're talking about a machine that can make a gun, right?
Yeah.
And that's just, if they don't understand what a 3D printer is, they don't get what I'm doing. So it's just really, I don't know, maybe it's a location, but I think, it's just a lot of working really hard to make it as easy to understand for people as possible.
What do you think some common misconceptions are about it?
Well, people get really angry when we try to call it 3D printing. I've seen that happen before. And usually just a blank stare where people just it's like I don't think they get it whatsoever. So I can tell when people give me a blank stare and they have no idea what I'm talking about.
Yeah.
It happens. Yeah.
So you say you believe that it's the future 3D printing?
Definitely. I mean, there's really, it's just gonna get. It's like Moore's law. Technology. That's how technology works. It gets exponentially better. And you can go on a website called Thingiverse, and right now there's hundreds of thousands of things you can download and print out, and they're all free. You can go on to Shapeways, and there's hundreds, maybe even millions of things that you can just order 3D printed objects that'll come to your house. So really, the future's already here. It's just taking time for people to catch up to it.
What's in the name Arcology now?
Well, so I got frustrated with. I just think that I see all these like really futuristic, fantastic visions of what buildings can be and whatnot, and they're all pretty and curvy and whatnot. But we honestly have no clue how to get there. It seems for a decent amount of money. It seems like all this stuff is either just too expensive or just out of reach, or we're just not going to make it. I think so. I wanted to do something that is the same equivalent but very low cost so that everyone could have it. The goal is just ultra low cost housing for everyone on the planet, and that's what the goal of Arcology now is. And we want to make these futuristic visions, but we want to do it with today's technology. We're not waiting around for the future.
Yeah that's good.
Yeah, because I really don't think people should have to work 40 hours per week. I don't think people should have to save up 30 years of their life for a mortgage. I think that's bullshit. And I want to destroy that. I want to obsolete that. That's my goal.
That's a good goal.
Yeah.
I agree with that.
Yeah. So it's first starting with low cost, freeform housing, and then I want to do automated greenhouses, because every house should have a greenhouse too. I don't see why greenhouses aren't as ubiquitous as like a refrigerator. It should be like a walk-in pantry full of vegetables, and it should be cheap enough that it's cheaper than going to the store, and it should be automated so you don't have to fuss with it. And it seems to me like something like that could have a really huge impact on society. But yet,
economy.
Yeah, and the economy, it'd cause a lot of problems actually. That's why I don't think it's been invented yet. But then the government goes and spends billions and billions of dollars on like F-22 or something.
Yeah, drones.
For that kind of money, we could feed and clothe everyone on the planet, and maybe they wouldn't want to shoot us anymore.
Yeah. Maybe we think we're all right.
Yeah. But getting that kind of funding for this kind of stuff is a little bit more difficult than getting funding for military ventures, it seems. But I don't care. I'm going to make it happen. Yeah.
Great. Well, is there anything you'd like to say to anybody who's listening right now?
Well, come out and see us build. Come out and build with us, because you really can't experience how this stuff works. It's really hard to understand it until you're actually right there with your hands on it. And it's a fun fun process. You know, you can drink beer, you can have pizza, and just build. It's like putting together a huge puzzle. People really get into it. Yeah.
Yeah, it's could be good for community.
Yeah, it's a good way to build community. And, you know, we can do art projects for, I'd say 10% of what people are used to paying. So, you know, art structures and whatnot. So it's really a revolutionary breakthrough.
All right, well, that's arcologynow.com. There'll be more links on this video thing. So thank you for meeting with me today.
Pleasure.
Yes, and I applaud what you're doing, and I'm
Thank you.
sure it'll work out too. I could see it, and I envision the similar future,
Cool.
if not the same.
Yeah.
Thank you.